Consider the area bounded by y equals 5x minus x squared and y equals x. If I sketch this, this parabola goes through 0 and 5. Oops. And that line y equals x looks like that. I want to figure out where they actually cross. So I'm going to let x equal 5x minus x squared. So 0 is 4x minus x squared. So it meets at x equals 0 and 4. So that's actually halfway decent in terms of scale. Okay, so I am going to give myself a generic little line, like I always do. Oops. So all of my integrals, for everything I do, I'm going to integrate from 0 to 4. Because that's what my region goes, from 0 to 4. Okay, so area is the integral from 0 to 4 of the top function minus the bottom function. If I go around the x-axis, then I will have a disk, or washer rather. So my volume is the integral from 0 to 4. So I have a disk, I need pi r squared. They both have pi, so I'll stick that one on the outside. The large radius is the top one, which is 5x minus x squared, minus the small one, x squared. If I go around the y-axis, I will get what they call a shell. Use a different pen. That's my red pen. So I get my little shell, and the volume of a shell is 2 pi RH. So 2 pi integral from 0 to 4. My radius is the distance from my axis to the x, so that's x. The height is the difference in the function, or the length of my little line. And length of my little line is 5x minus x squared. Oops, minus x. Okay, let's throw this thing around a whole bunch of different things. I'm not having luck today. Okay, so let's say about x equals 5. Here's my 5. Generic x, and that's the radius. Because this is parallel, so I will use shell. Volume equals 2 pi, integral from 0 to 4. My radius is 5 minus x. The height is, oops, the difference in my functions. What if I go around x equals -2, say? There's my same old, same old. I'm rotating it around this line. Let's see if I can put this, which means I have a ginormous cylinder, and that represents the radius, which is, oh, I did not write the right thing down there. This is a line -2. So my radius will equal x plus 2. So therefore my volume is 2 pi, integral from 0 to 4. My radius is x plus 2. My height is 5x minus x squared minus x for the bottom one. Oop, I like my dx. Dope. Okay, now let's wrap it around some y lines, some horizontal lines. Let's say we want to go around the line y equals 6. There's my line. So notice the outer circle here is generated by the lower function, because if I'm rotating around something above my region, the one farthest away from the line is going to be the outer circle. I realize I'm making all these hand gestures and nobody sees it. It's kind of silly. Anyway, so it's a disk, so we're dealing with pi r squared. So my volume is going to be pi times the integral from 0 to 4. The outer circle is the line y equals x. And the inner circle is created by 5x. Oh wait, that's not right. That's not the radius, Megan. Okay, 6 is the distance from here to here. X is from here to here. Oh, too fast. Too bad I didn't hear you scream, I want to roll for that. So integral from 0 to 4. The outer radius is 6 minus x squared minus the inner radius is 6 minus that curvy thing, which was 5x minus x squared. The last thing I want to do, well, let's do surface area. Maybe I'll do another slide for that. So if I rotate it about y equals -2, oops, probably should give myself room. So the outer radius goes from the axis to this point. That's the big radius. And the little radius is that. Can you see that? It's kind of hard to see. So volume is pi, integral from 0 to 4. The big radius is the outer function, or the higher function, 5x minus x squared, plus 2 more units. The inner circle is 6x plus 2. So those are the types of volumes I can ask you about, rotating it this way and that way and up and down and all around. And on my next one I'll talk about surface area and arc length.